solving exponential equations. So if we take a look at the two examples that we have up here, both of them are exponentials because we have the variable in the exponent. Okay, so these are known as the exponential equations. And what I need to do is I need to try to figure out, okay, can I find a common base for these? Now, in this case, 16 is the base, x is the exponent here. I want to try to figure out, can I rewrite 16 into a smaller term, meaning so 16, that's 2 to the 4th power. I can rewrite that then as 2 to the 4th raised to the x power. Can I rewrite 32 in base 2? Well, if 2 to the 4th power is 16, multiply that by another 2, I get 32. So I get 2 to the 5th here, and that's going to be raised to the x plus 1. What I need to do now is say, all right, well, wait a minute. If I was over here and I said I have 2 to the x is equal to 2 to the 4th, I would just say, okay, well, x is equal to 4. All I'm doing is saying, all right, well, the only way this is going to happen is if the exponents are exactly the same. So in this case, we're trying to get it so that we have the exponents are exactly the same. All right, so to prevent confusion, let's get rid of that so it's not just sitting there. Come back to this example. Remember, this is an x here. It's kind of hard to see. I'm going to basically ignore the bases of 2. Because since they're the same, then that means in order for this to be a true statement, the exponents have to be equal to one another. So the exponents here would be 4 times x. The exponent on this side would be 5 times x plus 1. Now we're right back to algebra 1 again. So 4x is equal to, distribute the 5. 5x, make sure you distribute it to both parts. Alright, I'm going to subtract x, and sorry, not x, but actually 5x from both sides. And I get that negative x is equal to 5, which means x is equal to negative 5. Alright, let's move on. Taking a look at this example, I have that this is in base 5, this one's in 25. I could rewrite 25 to 5 squared. Then I'm going to have that raised to a power of 2x. Over here, nothing happens because it's already in the base that I'm looking for. Again, we kind of just ignore the bases because in order for this to be a true statement, the exponents would have to equal one another. So I'm just going to make sure I don't skip any steps and lose anybody here, but I've got the 2 that's here, the 2x that's up here, so those are going to multiply. The only exponent I have over here is x minus 3. 4x is equal to x minus 3. Subtract x from both sides. 3x is equal to a negative 3. Divide both sides by 3. X is equal to negative 1. All right, so just a couple examples of just solving.